welcome to session 3 of Unit 4. This session will introduce you to analysis by means of radioactivity. By the end of this session, you should be able to do analysis by means of radioactivity. Let us look at some examples of analysis by means of radioactivity. The first one we shall be looking at is isotope dilution analysis. In isotope dilution analysis, a solution that contains an unknown compound is added to a known quantity of isotope or radioactive isotopes. This will lead to the formation of radioactive ions and compounds which can be separated, and the percentage of radioactivity can be determined. The radioactive material will be recovered to some percentage in this process. Hence, its original percentage can be estimated. Another method for analysis by means of radioactivity is neutron activation analysis, which is abbreviated as NAA. The NAA helps us to determine the concentration of elements in vast amounts of materials. Now, to do that, a sample is bombarded with neutrons. This will cause the element to form radioactive isotopes. So the radioactive decay path for each of these elements is used to study the spectra of emission of this radioactive sample, and the concentration of each element within it can then be determined. A particular advantage of this technique is that it has not destroyed the sample and thus has been used for analysis of works of art and historical artifacts. NAA has application in chemistry but also in other research fields such as geology, archaeology, medicine, environmental monitoring, and even in forensic science. Let us look at the applications of NAA. The NAA is a very important analytical method in radiochemistry. It is usually used as an important reference for other analysis. One of the applications of NAA is that because of its very high sensitivity, it is used to analyze minor elements which are present in very low concentrations. So even if there are only minute amount of certain elements in samples, the NAA can be used to detect and analyze them. Another important application is that it is useful for trace element analysis. The NAA can be used to detect trace elements in water and in other biological materials. Also, in archaeological studies, NAA is very important analytical method because it employs the fingerprint of individual elements in raw materials to give useful information about their origin. The NAA can detect up to 74 elements depending on the experimental procedure that is being employed. It has a detection limit that ranges from 10 to 7 to 10 to 15 gram per gram of the sample, and this also depends on the element and the matrix material. The neutron activation analysis technique can be put into two broad categories. One is the prompt gamma neutron activation analysis, which is abbreviated as PGNEE, and then delay gamma neutron activation analysis, which is abbreviated as DGNAA. Let's start with the PGNAA. In the PGNAA, gamma rays are measured during the neutron irradiation. The PGNAA technique is most applicable to elements with extremely high neutron capture cross-section. Also, elements which decay too rapidly to be measured by the DGNAA can be measured by the PGNAA. And also, elements that produce only stable isotopes, such as lighter elements, can also be measured by the PGNAA. The PGNAA is also applicable to elements with weak decay gamma ray intensities, and 3D and 2D analysis of element distribution in samples can be performed using the PGNAA. Let's look at the DGNAA. In the DGNAA analysis, gamma rays are measured at some time after the end of the irradiation. The DGNAA is useful for vast majority of elements that produce radioactive nuclides. The technique is very flexible with respect to time, such that the sensitivity of long-lived radionuclides that suffer from interference by short-lived radionuclides can be improved by waiting for the short-lived radionuclide to decay, or quite the contrary. The sensitivity for short-lived isotopes can be improved by reducing the time irradiation occurred to minimize the interference of long-lived isotopes. This selectivity is a key advantage of DGNA over other analytical methods. Other forms of the neutron activation analysis techniques is the instrumental neutron activation analysis, and radiochemical neutron activation analysis. So let's look at the instrumental neutron activation analysis, which is abbreviated as INAA. In the INAA, automated sample handling, gamma ray measurements with solid state detectors, and computerized data processing is utilized to simultaneously measure more than 30 elements in most sample types without any chemical processing. However, if chemical separations are carried out on samples after irradiation, so as to remove interferences or to concentrate the radioisotopes of interest that has been formed, the technique is called radiochemical neutron activation analysis, which is abbreviated as RNAA. And so this is basically the difference between the INAA and RNAA. You have on this page some trial questions which I would want you to discuss them to prepare yourself for any test that lies ahead of you.